Okay, round 3. Let's see if we can get this right and all my equipment can work. So, A, make sure you read the directions and do the parts that are answered. State if the polygons are similar. Write in needle angles to show congruent or not congruent. You're going to have to do that in number 2. Show unsimplified side ratios to show proportional or not. Remember, proportional isn't similar. It can show similarity on here. So, for number 1, we need to show all, for these problems, we need to show all the angles are congruent, all the sides are proportional. So for number 1, we're pretty good with that on all these right angles. So all our angles are congruent. So we have that pretty easy. Now we need to show our sides are proportional. So I'm going to go top to bottom. And then this is going to be my short side. This is going to be my long side. Don't have to write that down. You do need to think it. So that's going to go 4 to 8. Just going to move that up there. Long side from the top is 5 to 20. I can reduce that 1/2. It's not equal to 1/4. And I shouldn't have put it equals there because there's really a question mark. So that's not in proportion. But that's not your answer. You have to say not similar. You don't have to say not in proportion. You can show that to me. Okay, number 2. 110 isn't 70, so I got to check these. So I'm going to find this angle, and we can get these other ones too. It's a parallelogram, so opposite angles are congruent. Just remember, consecutive angles are supplementary, so I'm going to call that x. 110 plus x has to equal 180. And practice writing equations. I know you can subtract these, but if you write equations, you're going to get better in the long run. X equals 70 degrees. Oh, so that's 70. That matches. I could also do it over here. 70 plus x equals 110, or 180, minus 70, x equals 110. So that's 70, that's going to be 110, that's going to be 70, 110, 70, 110. I got congruent angles. So we're good. Now I need to show my sides are in proportion. So again, I'm going to go left to right. And I'm testing to see if that's an equals in there, because we need the equals. I'm going to do my short side and my long side. So that's going to be 4 to 8 for the shorts, 5 to 10, that's 1/2. That is equal to 1/2. It checks they're in proportion. Don't forget, you don't like reducing. You can always just 4 divided by 8, 0.5. 5 divided by 10, 0.5. Those are equal. They're in proportion. So the polygons are similar. Show that work. The next problem, again, read the directions, kids. The polygons are similar. I had people saying, yes, they are similar. No, they're not similar. They are similar. Find the scale factor. So that's what we're looking for next. Find the scale factor, the smaller figure to the larger figure. People were that. Show and reduce the ratios used to find the scale factor. I do expect these in fractions. I will give credit for decimals. It won't be full credit, but it'll be a minor reduction. Okay, so again, we need to go, remember, small to large is the same as small to large, which is small over large. Okay, so I only really need to do one of these corresponding sides right there. I can go 3 to 6, and I actually have it at 1/2. I can be done there. You want to check your work. You don't have to do this. 6 to 12. I'm going these hypotenuses. You can see that also equals 1/2. So we have it there. Now here, number 4, it's a little bit tougher. Okay, so again, I got to go small to large. Now, 15 and 18. Well, they give you two 20s here, so is that I can see 15. Actually, why I'm choosing 15. I look over here, and I look at this, and I can see right here that this segment is shorter than this segment. And then the same thing for the top ones up there. I don't really like the way that wrote. Okay, so, darn it, I wanted a different color there. So these segments are short, these segments are longer. So, geez, I got a 15 and an 18 here. I got information on the short ones. That means I need to use the short ones. So that's going to be 15 to 20. Geez, I can reduce both of those by 5. So I'm dividing by 5, I'm dividing by 5. That gives me 3/4. Or if you check an answer key, it'll look like that. So either one of those would be that. Again, read your directions. The polygons are similar. Find the missing side length. Show your proportions, show your work. Now, on these first couple, you're given the scale factor. On number 7, you're not, and you have to use the existing sides. So here, my scale factor is 3 to 4. So I have A to B, that's 3 to 4. So 15's in A, question mark. Now you can cross multiply here. 3 times question mark equals 15 times 4. Divide by 3. You can multiply that out first. I'm going to reduce right here. That goes to 1 and 5. That cancels out. Question mark equals 20. Should have given some more space on this one. It would have been nice. So that's 20. You might have also recognized, oh, you know what? That's an ugly 3. Why won't that erase? I can't figure out why this. Okay, let's write a better 3. You know what? I know that 3 times 5 equals 15, so I could have just done 4 times 5 and got my 20 there. Same thing over here. A to B, 3 to 4, 18 to question mark. Again, you could cross multiply. I'm going to use that multiplication. Hey, I know this is times 6, so this is times 6. That gives me 24. There's my answer. Now number 7 is a little bit more challenging. Okay, I got these corresponding, so I'm going to go, you don't have the scale factor, so you got to get it from the diagrams, left to right. Geez, and I'm going to go small and large. Again, you got to be thinking that. So that's going to be 20 to 12. I'm back. You probably didn't even know I was gone. So we've got 20 to 12. That's the small. The large is going to be 35 to question mark. Now you can reduce the 20 over 12. I'm not going to do that right away. I could cross multiply. I get 20 times question mark equals, sorry for the bad writing, 20 times question mark equals 12 times 35. Let's get this up here. 12 times 35, 420. Okay, so that's 420. I'm going to divide by 20. I'm going to divide by 20. And I get 21. Okay, so question mark equals 21. Now, I could have reduced this also. I could have reduced. That would have given by 4. That would give me 5 over 3. And then do my cross multiply. I'd get 5 times question mark equals 3 times 35. I'd divide by 5. 5 and 35 reduce to 1 and 7. Those cancel out. Those are actually going to 1s. 1 times question mark is 1. So question mark 3 times 7, there's my 21 again. Okay, you're not required to do it like that. I practice it because it's good practice. Okay, I'm back again. You didn't even know I walked all the way to Berkowitz's room and back here. So again, 8, 9, 10 are similar to 5, 6, 7, but we're solving for x this time instead of showing our work. Only one of them has the given ratio, 2 of them have that. I think I might change that for you though. We'll see here. I might shorten this up a couple more questions for the test. So again, we're given our ratio, A to B. Remember, that's A over B, 1 over 2. Notice A's on the right. I'm not going left to right. It's A to B, so that's going to be 3, over negative 2 plus 2x. Cross multiply. 1 times negative 2 plus 2x equals 6. Well, I don't really need those parentheses. Actually, let's just rewrite this whole thing again. That's just going to be negative 2 plus 2x plus 2 plus 2. Now on these problems, there are some people I see, doing some other work. Like some people are figuring out, oh, if that's 1 to 2, this has to be 6 and that sort of thing. Practice using the proportions. The proportions are what you're expected to use. And really, all I have to do to make this so it doesn't work, and I probably will put one question on the test like this, is like change this to a 3, and it's not going to come out, well, actually not the 3, but the previous problem. Practice using the proportions. It's a better skill to have. 2x equals 8. Divide by 2. X is equal to 4. Okay? Was just doing a quick check to make sure I'm not making any mistakes here. Now, on this one, make sure the parts are lined up. On this one, I noticed that this angle is a little bit smaller than this angle. Okay? So make sure you're getting the matching parts. I'm going to go top to bottom. Geez, these are corresponding. They both have numbers. 18 to 12 equals. I'm not going to use this number. It doesn't match up with anything. But I got this 21 over 3x minus 4. Now this one, I really want to reduce it. I don't want to be doing 18 times 3x minus 4. That just sounds like a hassle. Now I could reduce this by 6. If you don't see 6, hey, they're even. I could reduce this by 2, and that would give me 9 over 6. Hey, I can reduce that by 3, so that's going to give me 3 over 2 equals 21 over 3x minus 4. I like that a lot better. Notice if I divided by 6, 18 divided by 6 is 3, 12 divided by 6 is 2. I could have done that quicker, but if you don't see that right away, do what you can do. Even the 9 or 6 would be easier to work with. Now I'm going to cross multiply. 3 times 3x minus 4 equals 2 times 21. Now you can distribute if you want. I like to divide. The 3's cancel out. That just leaves 3x minus 4. Again, it's really 3 over 1 and 1 over 1, but I don't need the over 1. And then I would divide this side by 3. Oh, 3 and 21. That goes to 1 and 7. So again, that's 14 over 1. I don't need the over 1. It's there, but we don't write it. Plus 4, plus 4. And you get this stuff. You get this. Even if you make a mistake after that, it's going to be pretty minor as far as the point loss. You've got the majority of the points going. 3x equals 18. Divide by 3. And x is equal to 6. Okay, same thing here. Now, again, I think I'm going to take a question out of these last couple here just to make it a little bit shorter. Again, no, I'd do it now, but I have to redo this whole video and there's no time. So, left to right, same approach as the last one. Corresponding sides, 12 to 16. I got the same thing here. I don't need it, but I have 3x over 24. I'm going to reduce by 4 here. I could reduce by 2 twice, but 4, that's going to go to 3 over 4. So I have 3/4 equals 3x over 24. Cross multiply. I'm going to multiply this time 12x because I can see 3 times 24. I did 3 times 4 because that comes out to 12. I can see 12 reducing with my 24. Those cancel out. That goes to 1 and 2. 3 times 2 is 6. That gives me x equals 6. Good, I did circle those. Okay. I should have mentioned the directions up here. Solve for x. The polygons in each pair are similar. We know they're similar. Show your work. I expect to see that work. Okay. Are the triangles similar? State if the triangles are similar. If so, state how you know they are similar. That's your AA similarity, SAS similarity, or SSS similarity. If they are similar, you complete the similarity statement. Okay? If it's not similar, you don't. And then also note, mark congruent angles, show your proportions and work. Okay, so number 11. Let's go here. Well, I have a reflexive property right there. Angle E is in both this triangle and this triangle, so I can use my reflexive property there. Remember, parallel lines give us congruent angles. I have corresponding angles. That'd be congruent. I could have also gotten these congruent over here, but I didn't need them. I could have used these two angles, or this one, but I did those. My pen's getting temperamental. So, yes, they are similar. I'm using angle-angle similarity, which makes sense. There's no side information, so it can't be an SAS or an SSS. And then triangle. Don't forget the triangle. I'm going to mark down if you don't put triangles on this test. E's got to go to E. F goes to B. And again, that's because they're corresponding angles. You can see they're marked congruent. G would go to C, so that's EBC. Okay, number 12. If this one is similar, it's going to be SAS similarity. I can see I got an angle in there. I don't have to come up with any angles. No vertical angles on this one. I should have put a vertical angle in here. Sorry about that. I forgot. Okay, I was more looking at these type of problems I wanted to show. And then notice the sides that I'm giving include the angle. The sides include the angle, so that's heading for an SAS, if it's anything. Okay, so I got the angle. Whoops. I got the angle. I need to check my sides. So I'm going to go top to bottom, my short one, my long one. That's going to be 2 to 16, and I got to check, does it match up with 4 to 32? Well, we can see this one. I could reduce this by 2. That would go to 2 to 16. Oh, those are the same. I could reduce them again. That's 1/8 equals 1/8. This reduction would be enough to show that they're in proportion. So this is a yes. The polygons are similar, or the triangles are similar. And then I got to have D, E, F. Well, D is that angle, so that's going to go to T. E. When I go from D to E, I'm going down the short side. So T, go down the short side to U, and then V is the one I have left. I should be circling my answer parts here. Okay, now these were some I got to think of. So if they told you this is 11, how did I get 11? 5 plus 11 gives me 16. This setting up like 4 to 13 and 5 to 11, that can work in some situations, but it's not going to match up with the 2 to 8. It'll never match up with the 2 to 8. You have to make sure you're using the whole sides here. So you could do SSS or you could do SAS here, because we got this angle congruent right there. That gives me an angle. This side is 17. Okay, so I'd have, I'm going to go small to large triangle. And then I'm going to go 4 to 17, and I got to compare that 5 to 16. And then that's all I really need for the SAS. If I'm doing the SSS, I'd need to compare it to 2 to 8. Well, 2 to 8, I can see it goes to 1/4, which is 0.25. 5/16, 4/17, I can't reduce them. They're not equal. They're not in proportion. Again, you can always take out your calculator here. Where are my numbers? 4 divided by 17, 0.235. That's 0.235. 0.25 divided by 16, 0.313. Notice I have to round it up. 0.313. These are not equal. These are not equal. So this one is not similar. Again, if I was doing SAS and I showed my congruent angle here, I'd only need these two. If you don't recognize the congruent angle, you can do SSS and you would need that. Neither of them work. So that's it for that one. Again, on this side, I want a different color. Looking this way. Oh, from here to here, that's 16, just so we know. So again, I'm going to go, again, this could be an SSS or an SAS. I got my angle that's in this triangle and in this triangle. So I got that reflexive property. Or I could use the third side. So let's set this up. So I'm going to go the small triangle to the large triangle. I wanted the red. Small to large. 4 is the side in the small triangle. 16 is the corresponding side in the large one. Okay, and then I'd have 7 to 28. Those are the only two sides you need if you're going for an SAS proof. If I'm going for the SSS, I would need the 6 to 24. Now notice these are all equal. These all reduce to 1/4. Again, I should have put question marks in there. 1/4 or 0.25, 0.25, 0.25. So those are all equal. Notice if I would have just done the 4 to 12, that would reduce to 1/3, which is not equal to these other ones, and I would have gotten the problem wrong. So these are yes, they're similar. You could do SAS similarity or SSS. You don't have to tell me both. And then again, I need my triangle here. L's got to go to L. K is up that side. F is the corresponding part there. F. And then I'm going to have J and G, so LFG. And that gives me that one. Interesting. Okay, that takes us to the end. I may shorten this up a couple more questions again. I hope this gives you some help. Do well, make me proud. I know you can do it. We'll catch you later.